Okay, combining radicals has a simple two-part process. First, you're going to, combining means adding and subtracting radicals. So first you're going to simplify all the radicals involved in the problem. And then you're looking to combine, add, or subtract, but only if the index is the same. And the base is the same. So if the index and base have to be exactly the same for each term, this being added or subtracted, that's the only way you can combine radicals. Okay, so if I gave you this, root 5 minus root 2, what's that going to equal in the simplest form? Is it going to be square root of 3? Do they have the same index? Yeah, both square roots. Do they have the same base? No. One's a 5, one's a 2, so you can't combine these. Your simplified form is just going to be rewriting the form they gave you. Okay, what if I gave you something like this? Can you combine these? Same index, square root, same base, 5. So now you can, it fits this pattern, so you can combine whatever's out front. 3 minus this unwritten 1. 3 minus 1 is 2. Root 5 would be your simplified form for that. And what about this one? Root 2 minus root 50. Can you combine these? Are they the same index and base? Not in this form, but what if you simplify all the radicals first? 8 root 2, it doesn't simplify any further, but are there any perfect square factors you can remove from 50? 25, the square root of 25 comes out as a 5, the 2 stays inside the radical, and now does it fit this second condition? The index is 2, square root, the base is also 2, so you can combine them. 8 minus a 5 gives you 3. Root 2 would be your solution. Okay, so look to simplify the radical, then check and see. Can you combine it only if the index and base are exactly the same? Okay, on page 16, I want you to try sample problem number 10 really quickly, and then I'll give you some time to work on your assignments. All right, if you're looking to combine the first pair of terms, are they like terms right away? No, so we need to simplify first. Are there any perfect square factors you can remove from 27? 9 times 3, so you have this factor of 2. The square root of 9 comes out as a 3, and this factor of 3 stays inside the radical. What about the second radical? Are there any perfect squares? Oops. Any perfect squares that you can remove from 75? Also 25 times 3. So you have this factor of 5 out front. The square root of 25 comes out as another factor of 5. Square root of 3 stays. And so now if you simplify, 2 times 3 is 6 root 3. 5 times 5, 25 root 3. Can you now combine these two terms? Index of 2, a base of 3, so yes, they have the same. So they're like terms. You can combine 6 minus 25 gives negative 19. Root 3 as your solution. Okay, do the same thing in B. Now, is it true that the square root of 5 squared plus 3 squared is equal to the square root of 8? Can you take the square root of 5, or the 5 squared and 3 squared, and just be left with 5 plus 3? No. So this is a common mistake. The square root cannot cancel the powers from individual terms being added together. And if you were to think of how this would apply on your calculator, and if you were entering this in your calculator, square root and then the parentheses and then the whole expression inside the parentheses, if you were doing order of operations, you need to do the grouping symbols first and do everything inside there first. So 5 squared is 25 plus 3 squared is 9. If you reduce that or combine it, you get root 34. Minus 3 times, now when you look at 136, okay, are there any perfect powers that are factors of 136? In order for these terms to combine, what factor will probably be remaining in this radical? Probably 34. So if we test it and see, 136 divided by 34 is 4. So you wind up, it is a perfect square. So if you simplify this, the square root of 4 comes out as a 2, root 34. So you're looking at root 34 minus 3 times 2 is 6. Root 34, combine your terms now. You have the values out in front. 1 minus a 6 is 5. Root 34 would be your simplified form. And now it's a negative sign, so that would be a negative out front.